Your text mentions bottom-up processes, and to tell you the truth, I think this is the less compelling explanation for perception relative to top-down. They, to your text credit, to Galati's credit, she gives many different examples of bottom-up, but I just don't find any of them terribly compelling in the human context, although in the machine context it could be. And just a sentence here. Psychologists studying perception distinguish between bottom-up and top-down processes. The term bottom-up essentially means that the perceiver starts with bits of information from the environment and combines them into form a percept. And this doesn't rely on a whole lot of experience. So let's see if I've got that paragraph here. So in this section, we'll focus on bottom-up models. The idea is that the system works in one direction, starting from the input and proceeding to a final interpretation. And whatever happens at a given point is unaffected by later processing. So it has no way of going back, if you will. For example, and some would say that even in humans, we have a template matching. So our financial instruments have numbers that are written in machine readable code, that the routing number of a check and other things, so that the amount can be debited from one account and credited to another. That's template. And these machine readable numbers have been the same, I can't imagine how many decades. We're probably going back to the 40s there. That's a long time. The machines decide which number is presented and, of course, make a sort of a decision there. Now, it's also the case that humans have a little bit of expansion on that. So, as you look over on figure 3.9 on the next page, is we have as this illustrates, a few problems with this. As a model of perception, template matching works this way. Every object, event, or other stimulus that we encounter and want to derive meaning from is compared with some previously stored pattern. The process of perception thus involves comparing incoming information with templates that we already have. So this check already has templates. So notice that this model implies that somewhere in our knowledge base we've stored millions of different templates, which is unlikely. So, as may already be apparent to you, template matching cannot explain how all of perception works. For example, this is your author had her students write cognitive psychology rocks, and all of them have different handwriting, but nonetheless, they're all recognizable. I can read cognitive psychology rocks irrespective of how they wrote it, within reason. So it begs a question, or raises a question, I should say. How can a template matching model explain your recognition of all 14 of those autographs, if you will, given that they have the same sentence? Well, is there a separate template for each variation? Probably not. It probably has more to do with feature analysis. So as I write, I'm staring down at one of my dogs curled up under the table. I'm able to recognize not only her, but certain parts of her ears, tail, etc. Some psychologists believe that such analysis of a whole into its parts underlies the basic process used in perception, and instead of processing stimuli as wholes, we might break them down into parts, and that's feature analysis. So this is a little crude, but an A, generally speaking, and this is, we don't have a template for every A, but what we have is a combination of features, has two parts that combine at the top, and then a horizontal part, kind of like the end of a swing set. A V is an upside down variant of that. I'm not sure why they drew it that way, but all sorts of letters that we could derive that could sort of tell us this. And that would enable us to be able to read things that were new. So the parts searched for and recognized are called features, and we combine those into a whole, even though they're subtly different. So for instance, and we'll get to this a little bit here. I'm going to fast forward just a smidge. Where the heck did it go? The top word, from our perspective, says they, and the bottom word says bake. Now, you'll notice that the second character is the same, but we've engaged in feature analysis in tandem with, or in combination with, some experience that's likely to be an H or likely to be an A. But nonetheless, the feature analysis part has to be there too. So that's the notion in reading, that it can't be the case that we have a template for everything that we've ever seen, because some things are unique. Thus, we must engage in some degree of analysis of features as we would have done with that handwriting. So even among these handwriting samples, you can see that I've got a lowercase g in cognitive and also an uppercase, but the lowercase g's and the uppercase g's look a lot like each other, with that uppercase g having a horizontal part and the top part that's kind of curved, etc. And you could make that generalization with just about any letter, especially the capital P's. And that feature analysis that I'm engaging in enables me to read it right away without any template that's stored. Now, this can be extended beyond letters, of course. And by the way, there's one thing I want to have you look at. It's one of the videos that's not part of the text that I made. It's the Hubel and Wiesel clip that's about 3 minutes long. And their original research dating to the 60s, and you'll hear from David Hubel narrating it, dealt with cats. And it's frankly kind of cruel research. They did have to euthanize these cats after these procedures. But the cats apparently had feature detectors in their brains, even though cats don't read much. If they do, they read Harry Potter, but they seldom read that. So the cats had visual orientation detectors and horizontal orientation detectors, etc. And when a line was given the opposite direction of what the feature detectors were designed for, the neurons went silent. But on the other hand, when it was correspondent for what the neurons were designed for, you heard a lot of crackling. Those are the action potentials that you might remember, etc. So it's right adjacent to this clip. You can watch that first 3 minutes. Of course, it's on YouTube. I'm so lazy, I can't get videos anywhere else. But it's a really fascinating suggestion that this featural analysis has got some validity to it. So as I'm reading these signatures here, the P's are subtly different, but they do share common features of having a loop at the top and a vertical stem, as do the S's, as do the Y's have common features. And without a template, I could arrive at it pretty darn quick and figure out what it is. Now, this could extend, some would say. There was a psychologist who I believe is still alive, Biederman. One of my other grad students, one of my colleagues, did an internship with him at USC. He extended this to the realm of objects, and he said all objects are reducible to a handful of what he called geons, and I believe it's 36. I can't remember. I can't find it. I think there are just 36 geons. I hope I'm not butchering that. But every conceivable briefcase or telephone or macaroni kernel or what have you can be reduced to an array of geons that we put together to recognize objects. And I got to give the guy credit. I think it's a bit of a stretch, but you got to take your hat off. He went to some lengths to identify a realm of perception that suggested that the world could be reduced to this many elements. You know, don't we do that in other branches of science? I mean, how many elements are there in the periodic table? I should know that. I don't, but it's a finite number, right? So might it be true that there's a finite number of potential physical shapes in the world? Yeah, maybe. It's not totally absurd. And that's Biederman's geon example. So it's the arrangement of geons that reveals a lot. There's another, and by the way, I've got another complement to the notes here on a visual search task that speaks of feature analysis. Neisser and others have confirmed that people use features to recognize letters. I think that's true. He had participants perform a visual search task in which researchers presented them with arrays of letters such as those shown in Figure 313. The researchers asked participants to respond if they detected the presence of a target like Q or Z. Such an array, as shown in 313, participants took much longer to find a Z than they did to find a Q. The reverse was true for arrays similar to 313b. And let me show you this. As you can see, and let me blow it up a smidge. Thanks for waiting. Sorry about this coughing. If I'm looking for a Z over on the left, it's a bit tougher because all the letters are angular. And that suggests I'm examining their features. So the Z is more easily confused with the W and the E, etc. On the other hand, if I'm looking for a Z over on the right, it's easier because all the letters are rounded, like D, R, and Q and U. So that's a suggestion that there's some feature analysis going on there. It's kind of an interesting idea, very, very direct. The feature analysis that I have in my video is one, the complementing video to this, has to do with colors and shapes. And it's a very clever experiment from CogLab that's only lasts about 2-3 minutes. Then there's categorical perception that has to do with sound. I'll let you read that. When people interpret speech sounds, we hone in on the acoustic features, such as voicing and place of articulation. That's an interesting section to read. And so we've also found that infants have shown tremendous discrimination between those subtle sounds, which is a suggestion that they can pick up on language at a very young age. And so that's a fascinating complement to the literature. By the way, they had an experiment one time where infants at a very young age would indicate excitement by sucking on a pacifier that was tethered to an electronic device, and they would eventually habituate to it. So the researcher would say ba, ba, ba over and over again, and within seconds the infants grew bored and stopped sucking so hard. But then when it was changed to pa, 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 they showed renewed interest away from that habituation, suggesting the ability to pick up on subtle differences in sounds.